Hello people, welcome back to the channel. Hope you are doing well. Today we are going to discuss the third question in Lead Code Weekly Contest, that is maximum tastiness of a candy basket. That means you are given an array of positive integers, that is prices, where price of I denote the price of ith candy, and you are also given a positive integer k. Basically what you have to do here is you need to sell baskets of k distinct candies. That means in a basket you have K candies, and the tastiness of a candy basket is smallest absolute difference of prices of any two candies in the basket. That means you are having K candies in a basket, and the tastiness of the basket is considered to be the smallest absolute difference of the prices of any two candies. So what you have to do is you have to return the maximum tastiness of a candy basket. So in this given example, example 1, the k value is 3. Here the answer is 8 because you can choose the candies with prices 13, 5 and 21. And the minimum absolute difference is 8 here. So what is the first approach that comes to your mind? If we are choosing the uh, if we are choosing if we are choosing a basket with candies, we don't have to check for every pair of candies for the tastiness, for calculating the tastiness, that is the smallest absolute difference of prices, because here instead of checking 13 minus 5, 13 minus 21 and 5 minus 21, if we can sort these values, we'll get 5, 13 and 21. Example For example, here in the example one, the basket was this. Instead of calculating the absolute difference between every pair, that is this, and this, you can actually sort this array. For example, 5, 13, and 21. Then you can only check for the adjacent elements, every adjacent pair of elements. Because if the absolute difference between these two elements, this pair is greater than k, then obviously the difference between these two will be greater than k, because here the elements are in sorted manner. So the first approach that comes to your mind is sorting the candies in the basket. By sorting the candies in the basket, you can actually reduce the computation time while calculating the minimum absolute difference. Then here we want to find the maximum tastiness of a candy basket. That means in every in every candy basket there is a tastiness value, and the tastiness value should be maximum. So what is the minimum tastiness that can be obtained? That would be zero, right? If we take a basket of all the candies with same prices, the tastiness would be zero. And what could be the maximum tastiness of a basket? That could be the maximum element in the prices, because if we are taking a basket like 0 and 13, that then the maximum tastiness would be 13, right? So these are the lower bound and upper bound for our answer, where our answer lies. These are the lower bound and upper bound where our answer lies. So, are you getting any idea, like it is in increasing fashion? That is, we have a lower bound and upper bound, and we want to calculate the answer. We want to retrieve the answer in between these two. So, the first approach here, which should come to your mind, is binary search, because we can actually sort the prices array. For example, after sorting the prices array in the example 1, here this is the prices array after sorting the example 1, and k is given as 3. So if we can somehow see that, so the lower bound will be 0 and the upper bound will be 21. Now, if we calculate the mid for this, it would be 10, right? L plus H by 2, that is 21 by 2, that is 10. Okay, now we'll see if we can achieve the tastiness of 10 by creating a basket of size 3 using this prices array, right? So if we are present here, we'll compare this and this. The absolute difference is 1, so this is not possible. We'll keep the I here and we'll move here and we'll see 1 minus 5 is 4. This is also not possible. Then we'll move here. 1 minus 8 is 7. Still it is less than 10. Now we'll move here. 1 minus is greater than 10. It is 12. It is greater than 10. So these two candies can be a part of the basket. Now we'll move ahead. We'll see with we'll compare this candy with any other candy. If there is any candy with where the difference is greater than 10. Now this is the only candy left. 13 minus 21 is less than 10. So 10 is not possible. Okay. Now L is 0 and H is 10. Now the mid value is 5. Now we'll see here. 1 minus 2 is not possible. 1 minus 5, still the absolute difference is less than 5. Now 1 minus 8, the absolute difference is 7, which is greater than 5. So these two candies can be part of basket. These two can be part of basket. Now we'll compare this with any other candy, because if we can compare this, if we can find a candy where the absolute difference between this candy and the other candy is greater than k, then obviously this candy and that candy, the absolute difference between these two will be greater than k, right? Because this is in sorted order. So now if the mid value is 5, that means if we are trying to check if 5 can be our answer, these two can be our candies, possible candies, and here 13 minus 8 is also greater than or equals to 5. So these three can be our candies in the basket of size 3. Now 5 is possible, but 5 is a possible answer, but we want to find the maximum. So we'll keep L equals to 5 and we'll keep the H as it is. And now 5 plus 10 by 2 is 7. Now we'll check if 7 is possible or not. Now initially we are here and initially we are here and we are checking these two cannot be the candies. These two, the absolute difference is still less than 7. These two, the absolute difference is equals to 7, so these two can be a possible candies. Now we'll check this with any other candy if there is any absolute difference with greater than 7. So these two, the absolute difference is 5, which is less than 7. These two, the absolute difference is greater than 7. So these three candies can be put in the basket. So these three candies can be put into our basket, which can form the absolute tastiness of 7, which is greater than 5. Previously we got 5 and now we got 7, where 7 is greater than 5. So 7 can be our answer. Now we'll see if there is any other possible answer which is greater than 7. Now L is 7 and H is 10 and the mid value for them is 8. Now we'll check for 8. In the same way, if you traverse through the array and see if the minimum difference is greater than mid or not and take that candy, you will find that these three candies fit into the basket and you can keep 8 as answer. 8 is our possible answer and now we are checking for anything greater than 8. So L will be 9 and H will be 10 again, and 10 plus 9 by 2 is 9. You cannot form a basket of size 3 by considering 9 as the absolute difference. So 9 is not a possible answer. You can find 10 is also no, 10 can also not be the part of if 9 is not an answer, 10 is also not an answer. So 8 is the largest answer we can have. So as said, initially we are sorting the prices array, and now this is the check function. We'll see it later. Now we are keeping the low to be 0 and high to be the maximum of prices, where we find the answer between them. That means this is the lower bound, this is the higher bound, and we are trying to find the answer between these bounds. Initially the answer is 0 and we are performing a binary search here. We are finding the mid here and we are checking if the mid is possible answer. That means by keeping mid to be the answer, mid to be the tastiness, that means the absolute difference, are we possible to pick the candies into the basket of size k? That means we will check the check function. Initially I equals to 0 and we are looping through the prices array from 1. We are seeing if the prices of I and the current prices of j, the absolute difference between them is greater than or equals to answer or not. That means greater than or equals to mid or not. If it is yes, that means we can pick both the candies and we can search for the other candies until we get at least k candies. Here I passed k also. I passed k minus 1 because initially we are keeping the candy 0 to be, that means prices of 0. That means first candy to be our candy and we are checking for the remaining k minus 1 candies. You got it right? Now, after traversing through the whole array, if we are finding at least k or greater than k candies, we will return true or else we will return false. And if the mid is a possible answer, we are updating the answer with the mid. And we are checking for the other possible answers which are greater than the current maximum answer by keeping L equals to mid plus 1. And if it is not possible, if the current mid is not possible, we are checking for any lower possible answers by keeping h equals to mid minus 1. At the end of the program, we are returning the answer. So this is the solution for the third problem. So thank you guys. If you like the video, please like the video and subscribe to the channel.